Hi guys, let's solve question number 1 of biweekly contest 181. Question is valid digit numbers. Okay, you're given an integer n and a digit x. A number is considered valid if it contains at least one occurrence of digit x and it does not start with digit x. Okay, return true if n is valid, otherwise return false. Okay, let's see what the example is. Example is n is equal to 101 and x given is 0. So what question says a number is considered valid if first condition is it contains at least one occurrence of digit x. Okay, so in this number n, if you see the x is 0, right, and there is at least one occurrence of x, that is at this digit if you see in 101, right? So here one 0 occurs once. So yes, this satisfied the first condition. What is the second condition? It does not start with the digit x. So if in this number, if you see the first digit is 1, it is not x, which is 0. It's not 0, right? It's 1. So that is why it satisfies both the condition. So hence it is a valid number. Okay. Now let's see the another example. Here n is 232 and x is 2. Okay. Now if we see there is one occurrence of 2 in this number n here, then another occurrence is here. Okay, so if I just see the first condition that there should be at least one occurrence of digit x, yes, there is at least one. Instead there is two occurrences. But what does the second condition says? It does not start with digit x. But if you see the starting digit of this number is 2, which is x, right? But here question clearly said it does not start with digit x. So since it violates the second condition, it's not followed. So that is why it's not a valid number. So this condition is not being followed. Okay, so and one more thing, if you see the constraint, so n is up to 10 to the power 5, which means there can be up to 6 digits only in the number. Okay, so these are 5 zeros and this one, so n can be up to this, which means 6 digits only in the number. It will be only 6 digits, and x is from 0 to 9. Okay, so we have to compare only just this digit, if it there is only occurrence of 0 in this number or not. So what we can do is, in given number we can start our iteration from least significant bit, that is this one, and I can start iterating going here, here and so on, and I can see if there is at least one occurrence of x or not. If it is there, then what I can do is I can keep one boolean variable found, that I found a occurrence. Okay, so if I found a occurrence, I'll keep change the variable boolean variable, found. So initially it will be false. Now started with here, so I found 2 and x was also 2. I found, okay, this is 1, so I will mark it as true, that I found this occurrence. But I need to check this first digit. Okay, first digit is what most significant bit, right? So that is most significant digit in this number, if you see. So for getting this number, we need to iterate all over from here till here, and then I will find this digit in this number, and then if I find the digit, so I need to check, okay, if this digit, the last one, if this is equal to x or not. Since I see this is equal to x, so I'll return false. So one is the last condition that I'm checking is it should be found. Okay, there should be an occurrence from here only. I mean, not excluding this, there should be occurrence. We are not including in occurrence, we are not including the first digit. Okay, so except the first digit, in the remaining digits there should be an occurrence, which means I have found an occurrence, and the first digit, okay, should not be, so first digit should not be equal to x. If this is the condition it satisfies, then we can return true, or we can return, else we can return false. Okay, so this is the simple question for this. Now I can simply write the code for the same. So in code, if you see, we have this boolean flag found, which will be initially as false, and I need to have my loop running, which will be, since I need to iterate only till this part, basically everything except the first index, right? So I can keep say it as n is greater than equal to 10. Okay, and here I need to check if n mod 10, which will give me the digits every time, the last digit in this number n, if this is equal to x, which means I have found my one occurrence of x. So found I will mark as true. Okay, Now what else I need to do is, if I have found the occurrence, um, I mean, even if I have not, so I need to move this n to, I mean, I need to find next, right? Next n every time. So initially n will be 232. Now it will give me this as the least significant bit. Now next I need 2 3 as my number n, so that this will be my least significant bit, and I can check if this is equal to x or not. So basically we are checking digit by digit, right? Or you can say bit by bit. Okay. So for that reason I need to divide n by 10 every time. Okay. So n equal to n divided by 10. And at the end I need to check if we found one occurrence and n is not equal to x, which means we have found, so we can return true, else we can return false. So this is how this question is, and this part is, if since we are comparing n is greater than equal to 10, right? So at the end, if I next one would be when I divide it, so it will be 2, right? So 2 is not greater than equal to 10, so it will break from this loop and it will come here and it will check. Okay, so now if we it checks here, so n is 2 and x is also 2, which is equal, so this condition is not satisfied, so we will return false from here. Okay, so sorry, not um, I mean I can keep it as n also, or n mod 10. Yeah, this should not be equal to x. So yeah, and now if we see the time complexity for this question, so we are having this while loop going all over till the digits, and here if we see how many digits it can be, it's 10 to the power 5, so it max it will be 6 digits only. And since we will be iterating for 5 digits only, I mean last one we don't need to iterate through, so time complexity is O of 6 or 5, whatever you can say, and space complexity we are not taking anything additional, so it is O of 1. Yeah, so that's all about this problem. I hope you like this video. Thank you for watching.